Hello friends, welcome back to my channel. In this video, we shall have a quick revision of few concepts based on sets, which will be helpful for the aspirants, those who are preparing for Gpstr exam 2022. And along with sets, the cardinal property of set and Venn diagrams also we'll discuss about. So before moving to the video, if you are new to the channel, please do subscribe and press the bell icon so that you will get the notifications of the videos we upload here related to mathematics and science concepts, which will be helpful for Gpstr exams, TET, and even for central TET also. So you have already learned the basics. On moving to the topic sets, the set is a collection of well-defined objects, and we represent set in the flower bracket like this, and inside there are elements will be written. It could be of number or it could be of things or symbols also. Okay, and let's move into the topic directly. We'll check out with the properties of set. If you consider A and B are two sets, then A union B is equal to B union A. You can write like this. So this property of set is called as commutative property. And A intersection B is equal to B intersection A. Next is A union B of union C can be written as A union of B union C. Then A intersection B of C can be written as A intersection of B intersection C. Next one, A union of B intersection C can be written as A union B intersection A union C. Then A intersection B union C is equal to A intersection B union A intersection C. Next, A union B dash, whole dash. Like this, if you write, it is whole dash, it represents complement of set. Okay, is equal to A dash intersection B dash, and A intersection B whole dash is equal to A dash union B dash. So this property is called as De Morgan's law, and the above property, the first two properties are commutative property, these are associative property, and this relation shows that De Morgan's law. On moving to the cardinal properties of set, imagine if you write set like this, A is equal to 1, 2, 3, 4, 5, and there are 5 cardinal numbers. Therefore, n of A is equal to 5. And this is the main formula to write all the cardinal properties of the set. N of A plus n of B, it means number of cardinal elements, numbers in A plus number of cardinal elements in B, which is equal to n of A union B plus n of A intersection B. Remember this formula, this is a very basic formula. From there we can obtain all this remaining formula. Suppose you need the value of only n of A union B. Shift this A intersection B on the other side, so it changes as minus. We want only this value. Therefore, n of A union B is equal to n of A plus n of B minus n of A intersection B. If you want only A intersection B, keep this intersection B here only. Shift this A union B other side, becomes minus. N of A plus n of B is equal to n of A union B. If you want only this value of n of A, shift n of B other side. N of A is equal to n of A union B, n of A intersection B minus this NB. Okay. If you want NB, shift this NA the other side. So this is the basic formula so that you can obtain all the remaining formula. If A and B are disjoint sets, then A intersection B is equal to null set. Okay. If there is no common element, we'll be learning about that disjoint sets now. Already you have learned, just to recall now. N of A intersection B is equal to 0. Therefore, if this term in A intersection B is equal to 0, here the whole term becomes 0. Therefore, n of A union B is equal to n of A plus n of B. So remember these points. Let's recall about types of sets now. Finite set. A set in which is having the finite set of elements are called as finite set. You say it is well defined 0 to 10 numbers. Okay, it is finite set. If it is an infinite set, a set which contains infinite number of elements. So starting from 2, 4, 6, it goes on dash 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 like this. So this is infinite set. If an empty set or null set, a set which contains no element in it, okay, just a flower bracket. This is an representation of null set, or you can represent like this also 5 null set. Remember, suppose if it is written like this, a set inside that there is an element 0 element. This is not a null set. 0 is also an element, okay, remember that. And number of elements in the null set is equal to 0. Disjoin set, it means imagine two sets P and Q, 5, 7, 9, 4, 6, 10, 12. If you compare this two sets, if you take these two sets, there are no common elements. So if there are no common elements in the set, that sets are called as disjoint sets. If they are joint set or overlapping set, if they have at least one common element among the given sets. So 0, 2, 4, 2, 6. So common element is 2. Hence at least one common element it has. It could be more than one also. Next, equal sets. If A is equal to 10, 20, 30, even B is equal to 10, 20, 30, it means if two sets are having equal elements, then these sets are called as equal sets. Equal elements, the elements should be the same. Equivalent set. If two sets are having equal number of elements, then it is called as equivalent set. For example, x is equal to 1 to 3, y is equal to ABC. Here the elements are different, but the number of elements are same, equal. Here 3 elements, here 3 elements. N of A is equal to N of B. So this set is called as equivalent sets. Cleared? Let's look into a sum now. Suppose a set U, that is universal set, if it is given 1, 2, 3, 4, 5, 6, 7, 8, and A, B and C are subsets of this universal set, we call, and this will contain the elements of the universal set. Hence these are called as subsets of universal set. And how do we write A union B? A union B, the elements in the set A and the elements in the set B. And we have to combine these two and write all the numbers together in a set. There should not be any repetition of the numbers. You see, 1, you have written 1, 2 here, and even in B also, only ones you have to write. Then 3, ones, then 4, 5. And this is a set for A union B. If it is A intersection B, we have to write the set A and B. Among these two, which is the common element? 2 is common here, even here. Even 3 is also common in both the sets. Hence 2, 3 is of A intersection B. For A dash we find here, you compare universal set and set A, which is a common element in this A and U. 1, 1 cancel, 2, 2 cancel, 3, 3 cancel. What are the remaining elements in U? 4, 5, 6, 7 and 8. So this is A dash. For B dash, consider B and U. Cancel the common elements. 2, 2, 3, 3, 4, 4, 5, 5. What are the remaining elements? 1, 6, 7 and 8. So 1, 6, 7 and 8 are for B dash. Okay. If it is A union B whole dash. So already we have got the value of A union B here. For that whole dash, we have to compare with the universal set. Cancel the common elements 1, 2, 3, 4, 5. So up to this number it is cancelled. What are the numbers, elements remaining in U? 6, 7 and 8. So 6, 7, 8 is the A union B whole dash. If it is A intersection B whole dash, compare A intersection B with the universal set. 2, 3, cancel the common element and the remaining elements in U, that is 1, 4, 5, 6, 7 and 8. 1, 4, 5, 6, 7 and 8 gives us A intersection B whole dash. If you want to find out A dash union B dash, we have to consider these two sets and write the common, combine the elements and write 1, 4, 5, 6. Once you can write enough, 7, 8. So that is A dash union B dash. If it is A dash intersection of B dash, we have to look for the common in both. 6 is common, 7 is common and 8 is common in both. Writing that, let us solve another sum. If U is equal to, some elements are given and A value is given, B value is given, we have to verify that A union B whole dash is equal to A dash intersection B dash. So you can write A union B first in order to solve this. A union B, combine this A and B and write, that is 8, 16, 24, 16 only once you write is enough, okay, 4, 20, 28. So all this number. Better you can arrange in either ascending or descending order, it will be useful, it will be easy. Even if you write like this, there is no wrong in this, okay. And you got the value of A union B. Now A union B whole dash. So we have to compare this with the universal set. So cancel the common in both. 8, 8, 16, 16, 24, 24, 4, 4, 20, 20, 28, 28. What is remaining? Only 12 is remaining. So that is A union B whole dash. Take as equation number 1. Next we need to find out A dash B dash and then intersect both. A dash value will be, compare this A and universal set. Cancel the common. 8, 8, 16, 16, 24, 24. Write the remaining in U, 4, 12, 20 and 28. That is A dash. B dash, compare this to 4, cancel the common, 4, 16, 20, 28. What are the remaining? 8, 12, 24. So that is B dash. Now we have to find the intersection of this two. It means common in A dash and B dash, which is common in A dash and B dash, 12. Hence 12 is equation number 2. Compare equation 1 and 2. 12, 12 we got. Therefore A union B whole dash is equal to A dash intersection B dash. So these type of sums I think you can solve, which is very easy. So on moving to Venn diagrams in sets. Venn diagram is the most commonly used pictorial representation of sets. Usually this is represented in a rectangular box. Inside that they draw circles to represent the each individual sets, okay. And sometime oval shape also they draw, no problem. Generally it will be of circle in shape. So if this figure is given, Venn diagram is given, how to identify the sets now? Let us take this circle. This represent A. So what are the elements of only this A? 1, 2, 3, 4, 5, 6 and 7 inside this circle. So A is up to here. For B, 6, 7, 8 and 9. Okay, if you want to calculate A union B, combine this two and write 1, 2, 3, 4, 5, 6, 7, 8, 9 up to here. And A intersection B, 6 and 7, which is common in both. So in order to shade, suppose if they ask only to find out about A intersection B in the Venn diagram, you have to draw like this, then shade this part. Like this if you shade, that shows A intersection B. If you want to shade A union B, you have to shade the entire part like this. If Venn diagram is given and ask you to find out the elements of the set, you can find out. Okay. So this diagram represents union of set A union B. Two sets A and B are given. After writing the elements inside the set, if you shade the entire A and B, so this represents A union B. Okay. Let's have a look into this given Venn diagrams now. In the first diagram, this green shaded portion represent only set A. You see, it could be of like this shading also. This represents set A. If it is A dash, other than this A, the remaining full portion you have to shade. It is already shaded with green color. Either you can shade by drawing the lines like this. So except A, this outer part that represent A dash, that is complement of A. If A and B are disjoint set, you need to write them separately like this. There is no joint overlapping here. They should be separately written and no shading for disjoint set. Okay. Suppose if A is a set and B is a proper subset of A. So A you should write as a bigger set and inside that small b. So B is a subset of A and A includes B. So you can write like this also, B belongs to A. If it is A intersection of B, already we learned that we shade the middle part where they overlap. If it is A union B, the full thing, entire thing of A and B you have to shade. Clear? So these are the basic ideas of set related to set properties and Venn diagram. In the following classes, we will try to take, if you want to solve more sums, I think we have covered the basics. So working out on this basics only will be enough for the exam. If you want more, we will continue after completing the syllabus related to Gpstr exam. Okay. So if you like this video, don't forget to give a thumbs up. Thank you.